In tonight's video, we're going to look at section 4.4, which is on the chain rule. This is not going to be on test 7, but the test after that, so test 8. The chain rule. It says if y is equal to f of u is a differential, which remember, differential just means it has a derivative, function of u, and u is equal to g of x is a differential function of x, then the composition of those two functions, so f of g of x, is a differential function of x and is given by the following. F prime of g of x times g prime of x. Okay, so that would be right here at this section of the screen. So essentially it says if you have a function that's equal to the composition of two functions that are both differentiable, then the derivative is the derivative of the outside function, or f in this case, of your inside function times the derivative of your inside function. So a nice way to think of it is that the f is the outer function, so whatever that outer function is, and g is your inner function. So let's look at an example. In 8, we're given y equals 2 of 6 minus x squared quantity to the fifth. So we're going to break this up a little bit. What I'm going to say is y is equal to the composition of f of g of x, right? And notice that I can sub out the 6 minus x squared for g. So really this is y equals 2 times g of x to the fifth. So my g of x is going to be equal to 6 minus x squared. And then that means that my outside function, or f, is going to be given as y, which is 2 of x to the fifth. Okay, so f of g of x is f of 6 minus x squared. So everywhere I see an x, I replace it with 6 minus x squared, which is 2 6 minus x squared to the fifth, which is equal to the y we were given at the beginning. Okay, so then we're going to follow our formula. It says that the derivative of this function, or this type of function, is the derivative of the outside function composed with the inside function times the derivative of the inside function. So first we need to find the derivative. So f prime is going to be 10x to the fourth, and g prime will be negative 2x. The last thing we need to find is what is f prime of g of x, right? That is going to be f prime at g of x. So that will be 10, and then everywhere I see an x, I'm going to replace it with my original g, so that's 6 minus x squared to the fourth. Okay, and so I'm going to fill in. So y prime is equal to f prime of g of x times g prime of x. So I'm going to copy, it's 10, 6 minus x squared to the fourth times a negative 2x. And you simplify that to negative 20x, 6 minus x squared to the fourth. Okay. What's nice about about the chain rule, though, is it allows us to develop our power rule definition a little bit more thoroughly. Because remember, if we had an expression x minus 1 to the fourth power, we couldn't take the derivative. But now, because of chain rule, we can. So the general power rule says that if your equation y is equal to u of x to the nth power, where u is a differential function and n is a rational number, then the derivative of that function is equal to the same thing as u to the n, which is n times u to the n minus 1 times the derivative of u. Okay, so let's look at some examples involving that. In 14, I've got g of x is equal to x squared minus 2x plus 1 all underneath a square root. So I'm going to rewrite this as g of x is equal to x squared minus 2x plus 1 to the 1/2. Using my general power rule, the derivative is going to be the exponent times the original function, take away 1 from the power, times the derivative of that function, so 2x minus 2. So it looks very similar to chain rule, and in fact, it is very similar to chain rule. So when we simplify this, this becomes 1/2 2x minus 2, x squared minus 2x plus 1 to the negative 1/2. You can leave it as such, or multiply that 1/2 through to the first expression, so that would be x minus 1, x squared minus 2x plus 1 to the negative 1/2. Let's look at one more example. In 20, we have y equals negative 5 over t plus 3 to the third. Instead of doing a quotient rule, because that would take a little bit longer, we're actually going to bring up that t plus 3, because the whole thing is cubed. So it's negative 5 t plus 3 to the negative 3. And now I take the derivative using our general power rule. So that's going to be negative 5 times negative 3, copy my function, take away 1, derivative of the inside. So this is 15 times t plus 3 to the negative 4. Or, if you want to simplify, 15 over t plus 3 to the 4th. Now let's look at 44. In 44, we have the function f of x is equal to 1 over x squared minus 3x to the square. And we want to find the slope at the point 416. So in order to find slope, the first thing I have to do is take the derivative. So I'm going to first rewrite f as x squared minus 3x to the negative 2. And then I'm going to take the derivative to get that slope. So f prime will be negative 2 times x squared minus 3x to the negative 3 times 2x minus 3. I'm going to leave it like this. The only thing I'm going to do is I'm going to bring down that x squared minus 3x to the negative 3. That way I only have positive exponents, so when I plug in my 416, it's a little bit easier. Okay, so there's my derivative. Slope is going to be equal to f prime at the x value, so that would be 4. So this is equal to negative 2 times 2 times 4 minus 3 all over 4 squared minus 3 times 4 quantity cubed. So this is negative 2. 8 minus 3 is 5 over 16 minus 12 cubed. So this would be negative 10 over 4 cubed, which is 64, so negative 10 64ths, which simplifies to negative 5 over 32. Let's make it a little bit more complicated. So now we're going to have a function f of x is equal to 9 minus x squared to the 2/3, and our point is 1, 4, and we want to find the tangent line. So first thing I do for tangent lines is find my slope. So to find the slope, I'm going to take the derivative, and I'm going to use chain rule, so that's 2/3, 9 minus x squared to negative 1/3 times negative 2x, like so. Okay. And then I'm going to simplify by bringing down that 9 minus x squared to the negative 1/2. So this is 2 times negative 2x over 3 times 9 minus x squared to the 1/2. And then now I'm going to find my slope by plugging in 1, which is my x value for my point, into my derivative. So it's 2 times negative 2 over 3, 9 minus 1 to the 1/3, not 1/2. So this is negative 4 over 3 times 8 to the 1/3, or the cube root of 8, which is negative 4 over 6, because it's 3 times 2. So our slope is going to be negative 2/3. Now I need to find the equation of the line using the slope I've just found and my point given, which was 1, 4 as a quick reminder. So I'm now going to plug in, so I get 4 equals negative 2/3 times 1 plus b. So this is 4 plus 2/3 is equal to b. Get a common denominator, solve, so that's 12 plus 2 over 3. So this is equal to 14/3, which is our y-intercept. So my equation is y tangent equals negative 2/3 x plus 14/3. Last thing we're going to look at is what we kind of started to look at the end of class on Thursday for D block. Okay, so in 60 it says f of x is equal to 1 over x minus 6. Find the second derivative. So remember, second derivative is just taking the derivative a second time. So f prime, in order to find that, I need to first move up that x minus 6. This is x minus 6 to the negative 1. That way I don't have to do quotient rule. And then take the derivative of that using my power rule. So negative 1 times x minus 6, negative 2. Derivative of x minus 6 is 1. So this is negative x minus 6 to the negative 2. I'm not done though. I want to find second derivative, so I'm going to take the derivative a second time. So f double prime will be equal to negative 1 times negative 2, because negative 2 is my exponent, and negative 1 I had from before. Copy my inside, take away 1, take the derivative of the inside. So this will be 2 times x minus 6 to the negative 3, or 2 over x minus 6 quantity cubed. In 62, we have f of x is equal to 1 over square root x plus 4, and they give us a point 0, 1/2. They want us to find the second derivative at 0. So again, first thing I need to do, just like with the previous problem, is rewrite this as x plus 4 to the negative 1/2. Okay, that way I don't have to do quotient rule. Take the derivative of that, so I get negative 1/2 x plus 4, negative 1/2 minus 1, derivative of the inside is 1. So this simplifies to negative 1/2 x plus 4 to the negative 3/2. Okay, and so when you bring stuff up, make sure you watch your signs because that does change your answer quite a bit. And then, now that I have my first derivative, I need to take my second derivative, which will be negative 1/2 times negative 3/2 x plus 4. Negative 3/2 minus 1 is negative 5/2. And then the derivative of the inside is still 1. So this simplifies to negative 3/4 times 1 over x plus 4 to the 5/2. And then that 1 is there, just implied. Okay? We're not done though. We found the second derivative, but we need to find the second derivative at 0. So f double prime at 0. I'm going to plug in a 0 everywhere I see an x in my second derivative. So it's negative 3/4 times 1 over 0 plus 4 to the 5/2. So this is negative 3/4 times 1 over 4 to the 5/2, which is the same thing as negative 3/4 times 1 over 2 to the 5th power. So this is just negative 3/4 times 1 over 32, which simplifies to 3 over 128. And it should be positive because I forgot to change that to a positive sign, so negative 1/2 times the negative 3/2 is positive.